Today, we're diving straight into the fascinating mechanics of blood flow and looking at exactly what goes wrong when your body's most vital delivery system breaks down. We're going to explore the incredible physics keeping you alive right now and how modern medicine steps in like a master traffic controller when things go off the rails.
Here's our roadmap for this explainer. 1. The ultimate delivery system. 2. The physics of flow. 3. Pressure, arteries to veins. 4. When traffic slows down. 5. Spotting the warning signs. And 6. Clearing the roadblocks. Let's get right into it.
Section 1. The ultimate delivery system, your body's highway. To really understand poor circulation, we've got to start with what a healthy system looks like. Think of your circulatory system as a massive, non-stop delivery network. Its one and only job, bringing fresh oxygen and nutrients to your cells and hauling away the trash. To study this network, we look at something called hemodynamics. Simply put, this is the scientific foundation and study of how fluid actually physically moves through the complex segments of your vascular system. It's literally the physics of how you stay alive. And just look at the sheer scale of this operation. Your heart pumps blood through the systemic and pulmonary loops to incredibly demanding organs. We're talking about your brain, your liver, your kidneys. They all require massive, continuous deliveries just to function at a baseline level. To sustain that crazy demand, a staggering 5 liters of blood enter your aorta every single minute. And get this, that's why you're completely at rest. No running, no jumping. Just sitting there, your heart and vascular system are moving this massive volume to keep the delivery trucks rolling. Moving on to Section 2, the physics of flow, keeping the trucks moving. Let's look at how the actual physics of resistance and pressure manage to keep those 5 liters moving smoothly every single minute.
Now, the absolute crucial point here is resistance. Any force that opposes the movement of blood is going to dictate your flow, and this is heavily determined by the radius and length of your blood vessels. As you can see, short and wide vessels have way lower resistance, meaning much faster flow. On the flip side, long, narrow vessels create high resistance, slowing things down. But hey, it's not just the pipes, it's the fluid itself. The viscosity or thickness of your blood plays a massive role. Thicker blood equals more resistance. Simple as that.
Check out the stark contrast between these two types of blood flow. On the left, you've got smooth, streamlined, laminar flow. This is the dream, exactly what we want. But on the right, that's turbulent flow. The blood is moving in irregular, chaotic paths, constantly mixing and literally colliding with the vessel walls. Not ideal.
All right, Section 3, pressure, arteries to veins, the driving force. So fluid always flows from an area of higher pressure to lower pressure. Basic physics, right? This brings us to the pressure gradients that act as the driving force powering this whole entire system. The primary engine here is your heart. When the heart contracts during the systolic phase, it creates maximum pressure, usually around 120 millimeters of mercury in the large arteries. Then, when the heart relaxes and fills during the diastolic phase, we see the minimum pressure, sitting around 70 to 80. Together, these combine to create a mean arterial pressure that actively pushes your blood outward to your tissues.
But look at this dramatic pressure drop. Blood pressure falls off a cliff from the aorta all the way down to just 15 millimeters of mercury by the time it hits the venous end of your capillaries. At that point, the blood is moving at an absolute crawl, just 0.07 centimeters per second. But that slowdown, completely intentional. It gives the capillaries the exact amount of time they need to swap out oxygen, glucose, and waste with your tissues. Pretty brilliant design, right? Section 4. When traffic slows down, roadblocks to flow.
So, what happens when our internal delivery driver runs into delays, obstacles, or detours? What happens when the healthy physics we just talked about start to break down?
Seriously, what happens when this incredible, well-oiled delivery system hits a roadblock? Well, when obstacles block the path, it gets incredibly difficult for blood to reach the parts of your body that are furthest away from your heart, like your fingers and toes. The biggest issue? Your cells are left starving for oxygen, and without oxygen, they just can't function.
Now, here are the major culprits behind those roadblocks. Smoking chemically damages your blood vessels. High blood pressure physically pounds against vessel walls with way too much force, weakening them over time. Then there's atherosclerosis, where plaque literally piles up and narrows the arteries. Throw in things like diabetes, obesity, and deep vein thrombosis, which are blood clots, and they all act to either narrow the roads, damage the walls, or block the lanes entirely.
On to Section 5, spotting the warning signs, your body's alarms. Because we understand the physics of flow, the physical symptoms of these roadblocks make total logical sense. Your body is basically flashing its check engine light when it's not getting its deliveries.
When your tissues don't get the flow they need, you feel that lack of oxygen directly. It shows up as cold toes, numbness, and that super uncomfortable pins and needles feeling. Your muscles might hurt or feel weak when you're just walking because, well, they're starving for fuel. You might even notice a pale or blue skin color or bulging varicose veins where blood is actually flowing backward due to damaged valves. Yikes.
Finally, Section 6, clearing the roadblocks, restoring the flow. Fortunately, we aren't helpless when these biological traffic jams happen. Modern medicine has some incredible ways to step in, act as a traffic controller, and restore that vital flow. First off, medical providers have to pinpoint the exact location of the bottleneck. They start with a physical exam and medical history, sure, but they rely heavily on specialized testing. They'll use Doppler ultrasounds, ankle brachial index testing, and angiography to physically see exactly where the pressure is dropping and where the obstacles are hiding in your vascular network.
Once they find that roadblock, it's all about clearing the road. Surgeons can literally open blocked arteries with an angioplasty or bypass. Medically speaking, they can prescribe statins to stop plaque from building up or deploy blood thinners and thrombolytics to prevent and dissolve dangerous clots. Now, altering your blood's hemodynamics like this does carry a significant risk of bleeding, so providers have to work very carefully to get those dosages perfectly balanced.
So, I'll leave you with this to ponder. Knowing that you rely on this incredibly complex hemodynamic highway every single minute of your life, to the tune of 5 liters a minute, what steps can you take today to keep it clear? Exercise, healthy eating, and keeping your blood pressure in check can ensure your cells get exactly what they need. Thanks for tuning into this explainer, and keep on learning.